Welcome to the homework portal. This is your week 7 question number 3 and this will be published on 16th October. Okay. Now let us start this question. This is for 15 marks. I already started the timer. So within 15 minutes, will we be able to solve it or not? That's what we'll see. This is a challenge. Okay. A vertical wall carries a uniform positive charge on its surface. Okay. This produces a uniform horizontal electric field perpendicular to the wall. Fine. So there is a uniform electric field being seen. A small positive charge is being suspended in equilibrium from the vertical wall by a thread of negligible mass. So you have a pendulum basically, and this pendulum, the bob of this pendulum has lots of positive charges and there is an electric field here. Because of this, these positive charges are now repelling this, so it's making an angle over here. Okay, and it's not coming back, which means what? It is now in equilibrium. Okay, now with all this information, what's the next thing that we have? The charge per unit area on the surface of the wall is sigma. Charge per unit area is sigma, which can be given shown that the electric field strength E is sigma by 2 epsilon naught. So he has already given you the value of E, which is sigma by 2 epsilon naught. And what is sigma? Sigma is the charge per unit area. Let me write it down. Charge per unit area. So what is the use of this? If you ask me, if I find out what is the area of this wall, if I multiply this area, I can get the value of charge. Okay, that's what it is. So basically this is called as a charge density, surface charge density. Okay, demonstrate that the units of quantities in this equation are consistent, which means what? Whatever is the unit here, you should prove that this unit is also the same. That's how you need to do. So towards it, what we do is, let us do it something like this. What is the unit of E? E is nothing but electric field. Where do you use this one? We know that Q into E is equal to force. Electric force is nothing but charge multiplied by electric field. E is equal to F by Q. What is the unit of F? Newton. Unit of Q, C. So therefore unit of E should be Newton per coulomb. Okay, this is what we have for the units. Now we need to prove that this will also have the same unit. Now how do we prove this? Now sigma by 2 epsilon naught. Now what is sigma? Sigma is nothing but charge per unit area. Charge per unit area. What is area? Square meter. And what about this 2 epsilon naught? 2 doesn't have any unit. Epsilon naught is a question over here. So what we do is, to get the value of epsilon naught, let me write it down here. So where do we see this epsilon naught? We have seen this in 1 by 4 pi epsilon naught into Q1 into Q2 divided by R square is equal to F. Have you seen this? Where is this? Is in the Coulomb's law between the two forces, right? Two charges. What is the force of attraction or repulsion? So therefore we have this epsilon naught here. So we have 1 by epsilon naught. I'll do one thing. I'll take the value for epsilon naught. Epsilon naught can be written as, I'll push this epsilon naught upwards and F downwards. I'll have Q1 Q2 divided by F R square into 4 pi, right? Now what we will do is, let us write down the units over here. For coulomb, Q is coulomb and this is also coulomb, divided by F is Newton and R is meter square. 4 pi doesn't have anything. So therefore this should be coulomb square into Newton meter square. Okay. So let me substitute this over here. Coulomb square divided by Newton meter square. I'm not considering 2 here because 2 doesn't have any unit. Okay. So therefore now we have, what do we have here? Sigma here. So one C and the other C goes over here. This meter square and meter square goes over here. So what do we have in the numerator? We don't have anything in the numerator. It's 1 divided by coulomb per Newton, which should now be equal to Newton per coulomb. So what was it here? Newton per coulomb, Newton per coulomb. So this will give you complete full marks. Okay. So we have proved that this equation is consistent with the units. 2 marks easily you can get. Okay. Next question. The thread makes an angle of 30 degrees with the vertical wall. The ball has a mass of so much. Determine the horizontal force that acts on the ball. Okay, what is this question about? Drawing the free body diagram, getting the answer. Let me go back to the diagram here. So everything is clear. Okay, now what is that we need to do? This is very similar to that of what you have studied in your circular motion, right? So therefore what did we do here? Why is the ball hanging here? What are the forces? mg is the force acting here, and then tension is the force acting over here. Now why is it acting? Why is it standing here like this? The reason is, maybe what is he asking here? He is asking you to find out what is the horizontal force. Okay, when the horizontal force is required in circular motion, if you remember, we used to take the component of mg along this direction. Now I don't want that one. I will take the component of tension like this over here. Okay, the component of tension, see if this angle is 30, this angle will also be 30. Component of tension on the vertical y-axis is nothing but T cos 30, and along the horizontal axis would be T sin 30, right? We have resolved this over here. And what is the other force? See, if this force is acting like this, the ball should come like this. Why is it not coming? Because there's an electric field, there are positive charges here. These positive charges are getting repelled by these positive charges on the wall, so it is being repelled like this over here, which is your horizontal force. Now what you should write? You should now write the equations. What are the equations here? I can now write Fe is equal to T sin 30, and also this upward force equal to downward force, because this is equilibrium, right? So I will write T cos 30 is equal to mg. So now what we do, we cannot stop here. We cannot, since they are asked for horizontal force, you cannot stop here because the value of tension is not known. We need to get the value of tension from here, right? So tension T is equal to mg divided by cos 30. Let us substitute this. So when I substitute, what do I get? I get Fe is equal to mg divided by cos 30 multiplied by sin 30. Sin 30 is in the numerator here, right? So which will now be equal to mg tan 30. Now what's the value of tan 30? Tan 30 is 1 by root 3. So this will become mg divided by root 3. Now let me take this value and put it over here, mg divided by root 3. But he has asked you to get the value over here. What is the value of m? It's already given here, 0.025. So therefore Fe is equal to 0.025 multiplied by g value is 10 divided by square root of root 3. So let me find out what is that value. Where is it? It's here. So this should now be 0.025 star 10 divided by root 3 value is 1.73. So when I do this, I get the answer as 0.14. So the answer is 0.14 Newton. Okay. Now how is the marks been divided? 1 mark for deriving the FBDs. Which one? The x-axis equation. X-axis equation, what is it? Fe is equal to T sin 30. 1 mark for y-axis equation. What is it? It is nothing but you have mg is equal to T cos 30. Okay, and then finally 1 mark for simplification and answer. Okay, which is for 0.14 Newton. Okay, now let us move on to the next one. Just a moment, let me pull this one a little bit further. Okay, fine. Next, the charge on the ball is given by 1.2 into 10 power minus 6 coulomb. Determine the value of sigma. Okay, sigma. Now what is sigma? Sigma is surface charge density, right? So now what all do we know about sigma here? See, whatever new parameter is introduced in IB here, so though I have not taught you about sigma so far, okay, the information relevant to it will be given in the problem itself as a clue. Okay, so you should know where is that information. Now what is sigma known to you? How is the value of sigma known to you here? So coming back to this, you know E is equal to sigma by 2 epsilon naught. This equation is given. So let us write down that equation first. E is equal to sigma by 2 epsilon naught. But we also know E is equal to F by Q, electric force, right? Now Q is given here. Q is given here. Now what is F? We found out previously, as I keep on telling you. So whenever you are solving any problem in IB, so remember the solution or the input for this particular problem will come from the output from the previous problem. Okay, you already found out the force which was in the previous problem. So you can substitute here 0.14 Newton divided by 1.2 into 10 to the power of minus 6 coulomb. When I do this, I get the value of E. Okay, and then what I need is that I need the value of sigma here. This is what I need. Okay, if I get this value, I can get this value here. So now what I do, I'll not calculate this, I'll just keep it aside like this. Now sigma from this equation is nothing but 2 times epsilon times E over here. Now from here, this is 2 into epsilon naught value you are already aware from your data booklet. It's already given the data booklet, please check it out. Okay, which should be 8.85 into 10 to the power of minus 12. It will be given there. multiplied by whatever value you calculated here. You can use your calculator to determine this, or you can substitute it over here. 0.14 divided by 1.2 into 10 to the power of minus 6. Now let us do the calculation. This would be 2 into 8.85 multiplied by 0.14 divided by 1.2. Okay, it should be 2.065 multiplied by 10 to the power of, now use the 10 powers, here minus 12, here plus 6 when it comes upwards, be 10 power minus 6. So what is my answer? So let me check out the answer over here. So you get the answer as 1.77 into 10 to the power of minus 7. Where did we miss this? 0.14 Newton, right? Let me check it out. 0.14 Newton divided by 1.2 into 10 to the power 6, 7.2 10 to the power minus 6. Let me take my calculator once again. So 0.14 divided by 1.2 will be 0.17. 0.17 into, oh, this one I am looking at it. Oh, I'm sorry. 0.17, I'm looking at this one. So what is this now? Electric field I am getting, and I will substitute this value here. 2 times this multiplied by 2 multiplied by 8.85 will give me 2.065 into 10 to the power of minus 6 unit. What is the unit here? This is surface charge density, which should be coulomb per square meter. Okay, 2.065 into 10 to the power of minus 6 coulomb per meter square. Okay, let us move on to the next one. The thread breaks. Explain the initial subsequent motion of the ball. So what happens? Let me go back to the diagram. The moment this thread breaks, what will happen over here? The tension will become 0 here, right? The tension becomes 0 when thread is breaking. Then what can happen? Then this electric, the charge present here will get repelled by it like this over here, right? So therefore, due to the electric field, now let me write it down over here. This is the wall, which is having lots of positive charges like this. This is the ball over here. If this breaks, then what can happen? So this becomes the wall, once again is the same wall. The ball here, now because of this electric field, it starts moving like this. And because of gravity, it starts moving like this also. Which means the ball is now describing a, what kind of motion? Horizontal projectile motion. Okay. Now let us see, this is for 3 marks, so you need to mention 3 points at least here. The first point is that tension equal to 0. Second point is that because of mg, it moves downwards, and also since the ball is positively charged, it gets repelled by the charges on the wall, and then what happens? The resultant is hence the ball describes a horizontal projectile motion. Simple, right? Okay, whatever you have learned so far, you're just applying it over here. Okay, read the question and then understand what is that happens over here. Okay, then next question. What is the next question? Next question is here. Okay, the center of the ball, still carrying a charge of 1.2 microcoulomb, is now placed 0.4 meter from a point charge q. Okay, so this is what is the charge carried by it. They are given the charge over here. Okay, and then a charge on the ball acts as a point charge for the center of the ball. P is at a distance on the line. Okay, there is a point P, there is one more charge q here, and where the electric field strength is 0. At this point, your electric field strength is 0. Okay, and distance PQ is given. Calculate the charge on Q. State your answer to an appropriate number of significant figures. 3 marks. So why should electric field become 0? The reason is simple. See, this 1.2 microcoulomb positive charge will now try to have an electric field in this direction. You will have an electric field at point P in this direction. And this Q, what is this Q here? It says, so can it be positive or negative? It's from a point charge Q. It doesn't say anything about it, but now you need to know. See, if this was negative, it will also impose one more electric field like this. So therefore definitely this is not negative, this should be positive, so that this Q will now try to have an electric field in this direction. Okay, we already crossed the time. Okay, so therefore this electric field due to 1.2 microcoulomb will cancel with the electric field due to this, right? That's what is the equation. So now let us start with that. So therefore electric field at P due to 1.2 microcoulomb is equal to K into Q. What is Q here? 1.2 microcoulomb divided by distance square. What is the distance here? See, this whole thing is 0.4. This is 0.22. So this should be 0.18. 0.18. What is the unit? Meter. No, only 0.18 square. Why do I do this? Because the electric field at a point is given by KQ divided by R square due to a point charge. Okay. Then similarly, if I take the electric field due to this Q, this should be equal to K into, I do not know what's the value of Q. I need to find out Q divided by, what is R here? 0.22 square. 0.22 square. Now what I will do is, I need to equate these two because they are equal and opposite. Net electric field is equal to 0. So therefore EP of 1.2 microcoulomb is equal to EQ. When I do this, what do I get? K into 1.2 microcoulomb divided by 0.18 the whole square is equal to KQ divided by 0.22 square. Now this K and this K goes away. Now I need to get the value of Q. Q will now be equal to 1.2 microcoulomb multiplied by 0.22 divided by 0.18 the whole square. Now let us find out. This is my calculator. See here. Okay. Now this is 0.22 divided by 0.18. I get the answer is 1.22 square. Take the square over here, 1.49 multiplied by 1.2 once again. So I get this is 1.79. So the value of it is 1.79 microcoulomb. Now look at this. This has two significant figures. This has 2, this has 2, this has 2. Everywhere it is 2 here. So here it is 3. So what I should do? I should write this as 1.8 microcoulomb over here. Okay. So therefore we get this 1.8 microcoulomb is the right answer. Then last question, I think, outline without calculation whether or not the electric potential at point P is 0. Now this question states, see, at point P electric field is 0. Okay, will the electric potential also be 0? Okay, I can ask now. See, whenever you are studying about electrostatics, okay, you will have 3 important parameters: electric field, electric force, potential. Now which amongst them is 0 here? Electric field is 0. We have found out now. Okay, it's already given. What about the force? Force is also 0. Why? Because F equal to Q times E, right? So since E is 0, this should also be 0. What about potential? See, these are zeros because they were vectors. But potential is not a vector. It's a scalar. How do you find potential? Potential you find out by using this method, right? You find out what is the potential due to this charge, which is nothing but K, Q divided by whatever is the distance. Let us say R1, right? Plus, here what you do? Once again you take K and lift this upwards. I'll write K, then the small q divided by this R2. Is there any negativity here? No negative, right? So this will become negative only when one of the charges becomes negative. Here both are positive charges. So therefore this V will always be greater than 0. Okay, the potential will be greater than 0. So that's what it says. Outline without calculation whether or not the electric potential P is 0. So you should write 2 points over here. What are the 2 points over here? You will write V potential is a scalar, and hence potential is a scalar, and as a result of it what will happen? So you can see, just a moment. Okay, electric potential is not 0, and hence the potentials due to both the charges gets added up. Okay, and is greater than 0. First one. Second thing that you need to notice here is that when you have two charges plus q and plus q here, and in between if you ask me something whether potential is 0, What is potential? First of all, you need to do some work here, right? See, if you are trying to go in this direction, you are going against this. If you are trying to go in this direction, you are again going against this one here, which means you need to do some work. By definition of potential, we know that work done is equal to Q times V over here, right? V is the potential, work done is W, and if I put a charge Q here, so that's what happens. So therefore this V is equal to work done per unit charge. You definitely need to do work whether you are going in this direction or that direction. It is something like you are definitely going to spend money, okay, whether you are going in this way or that way. So therefore potential cannot become zero, okay, and hence either you can write this method or you can say using this method, okay. So based on both of them you can say that the potential cannot become zero. Okay, so with this I think we have come to an end to this question. Hope this question gave you a lot of information about how to find electric field, how to find potential and so on. Practice more number of questions. So these kinds of questions will really be helpful in making your subject at a more gripper. Okay, thank you once again.